Okay, so a little discussion on fluid power and horsepower, all right? We know that a horse pulling 150 pounds, 220 feet vertical is 33,000 foot-pounds of work, all right? James Watt wanted to know how powerful a locomotive was, so he compared it to a horse at the time and how much work it could do in 1 minute. That steam engine was capable of doing the same amount of work, so he qualified that as having 1 horsepower. And if we look at it, it basically means we take the 220 feet that it moved and the weight of the load that it was lifted at 150 pounds, multiply the two of them together, and that's how we come up with the number of 33,000 pound-feet of work in 1 minute equals 1 horsepower. When we go to look at hydraulics, we also want to come up with a calculation, and basically it's kind of a little bit similar to electrical current flow, where we have a volume or amount of flow, if you want, and in this case we're going to use 1 gallon per minute. We're using a pressure, which is kind of like a voltage, of 1 psi, and we're using a resistance of 1 square inch. All right, so and I have that all here. Area 1 square inch, pressure 1 psi, and the volume is 231 inches cubed per minute. Now that is 1 gallon, so 1 gallon per minute at 1 psi against 1 square inch. All right, so it's kind of similar to Ohm's law for current. All right, so 200 at an area of 1 square inch, and we put in a volume of 231 cubic inches, we will move the rod 231 inches. All right, that would be 231 inch-pounds of work done in 1 minute. But we need to break it down into foot-pounds. So we take that amount and we divide the 231 by 12. That'll give us a conversion from inch-pounds to foot-pounds. Then we take that number and divide it by 33,000 foot-pounds of work equals a horsepower. The number is very small, 0.0005833 horsepower. So to make it a little easier, what we're going to do is we're going to take this and we're going to use a reciprocal to 1, which is 1 divided by 0.0005833 equals 1714. Now you should remember that number, 1714. If you look on the left-hand side of your calculator, you'll notice that's on all up the left side, so bottom, top, bottom, middle, right? 1714, 1714. Keep saying it over and repeating it, and you won't forget it. All right, so I have some calculations on how to do this. I'm going to turn off the screen. And we'll go through the calculations. So, we're going to start with a pump displacement of 2.5 inches cubed per revolution, RPM of 1500, an efficiency rating of 90%, and a system pressure of 1200. This is the formula we need to know, to figure out. Now, with this information on our pump, we don't necessarily have the gallons per minute yet, so we have to figure that out. So I'm going to turn the camera a little bit here so hopefully we can see and we can follow along at home. My cameraman has a day off, I guess. All right, so I've gone ahead and done the math out. You can follow along at home or just pause this as we go if you want it, but I'll write it all out here so that hopefully explain everything. So in order to calculate pump displacement, all right, or get the flow rate in gallons per minute, we need to take our 1500 RPM multiplied by 2.5 inches cubed per revolution, which is going to equal 3,750 inches cubed per minute. All right. Now, let's look at the efficiency now. So we know that that's in a perfect world how much we would get out. So we're going to take this number now and multiply that by the efficiency rating, which was 90%. So it's 0.90. And what we end up with then is 3,375 inches cubed per minute. All right. Now, going a little further, okay? So that's still, we don't know what our answer is in gallons per minute. So we take this number, 3,375 inches cubed per minute, divided by 231 inches cubed per gallon. All right, and we end up with a final answer of 14.61 gallons per minute. Now, there are other numbers down here, and I've just rounded it up so that it should be easy to work with. All right, so let's go back to here and we can fill this in now. We know that we have 14.61 gallons per minute operating against a pressure of 1200 psi, and then divided by 1714. So, put the page down here. All right, so 14.61 times 1200 divided by 1714 equals 10.22 horsepower. And again, I've rounded it up to keep it simple. Now, that is how much horsepower it would take to operate this piece of equipment at that pressure. But you have to remember that this is a pretty precise number. What I would suggest with that is I would add 20%. All right? Because if this is my motor putting it in, power into my pump, I don't want to have to run the motor at 100% of the time. This should roughly allow me to work it at 80%. So if I add 20% to that, think of it like 2 horsepower in this case. So that would mean I would go out and I would look for a 12 horsepower engine to supply power, or my prime mover in this scenario. All right, that's that one.